In this tutorial, we're going to use Trig. I'm going to show you how to do Trig identities using the addition formula. And what I'm going to show you here is, in this example here, I'm going to prove that this here is exactly the same as just cos x. So whenever you start seeing now sine or cos with some brackets, with two terms inside brackets, you've got to start thinking of the addition formula. So we can expand that out by using this formula here. Sine alpha minus beta is equal to the sine of alpha cos beta minus the sine of beta cos alpha. So that's the addition formula we're going to use. So if we expand it out, first we're going to write down sine of 90 and then the cos of x degrees minus the sine of x degrees cos of 90. Okay, so it doesn't look the same yet, but this is a much larger expression here, but we can simplify this because the sine of 90 is 1. So that there, sine 90 is going to become 1, so it's going to be 1 times the cos of x, which obviously is just going to be the cos of x. And then sine x times cos 90, well the cos of 90 is 0, and 0 times anything is 0. So this bit all disappears, and all you're left with is 1 times cos x, which equals cos x. So that's how you can use the addition formula in trig identities. Now, a harder example of that is prove that sine alpha minus beta over cos alpha cos beta equals tan alpha minus tan beta. Right, so again, the first thing you want to do here is you want to look at just the left-hand side first of all. Forget about the right-hand side, look at the left-hand side. We can expand this top bit using the addition formula. It just so happens to be exactly the same one as this one here. So we'll expand it out, and let's see if it helps at all. Sine alpha cos beta minus sine beta cos alpha, and all of that goes over cos alpha cos beta. Now we can split this big fraction here into two separate fractions. We could rewrite that as sine alpha cos beta over cos alpha cos beta. And then we've got on the other side, we've got minus sine beta cos alpha all over cos alpha cos beta. Okay, still looking like the right hand side, which has got tan alpha and tan beta, but if we look at these two separate fractions, we've got terms on the top and on the bottom that are the same, which can cancel. So you're left with sine alpha over cos alpha. And the same over here, we've got a cos alpha here, and this cos alpha will cancel as well. So you're left with sine beta over cos beta. Now if you remember back to what we did in intermediate 2 work, the tan of an angle, that's called alpha, is exactly the same as sine alpha over cos alpha. So here, this can be rewritten as just tan alpha, and this here can be rewritten as just tan beta. And therefore, that is exactly the same now as the right hand side. So we have proved that this is exactly the same as this. Okay, I hope that helps with trig identities.